Okie dokie. We're going to start on this side, which I'm pretty sure looks like the front on yours because of the way I punch the holes. All right. 1, 2, 3, all eyes on me. Thank you. All right, we're going to start with multiplying radicals. So we've added and subtracted. We have simplified. Let's talk about multiplying. We're going to start by looking at number 1 and 4 at the same time, because these both have a squared on them, and we're going to talk about what we can do and what we can't do. All right, on number 2, when I have that 2 times the square root of 5, that is one term that is squared, we can use our exponent rules and distribute that squared, so it's 2 squared times the square root of 5 squared. Okay, and then we're going to pause right there for a second. Then we're going to look at number 4. What we can't do on number 4, this does not equal. We cannot just distribute the square. So that is not 3 squared minus the square root of 6 squared. That's the kind of thing that gets you sent to math jail. All right? Do you see the difference in these two things? Number 1 has one term. Number 4 rather has 2 terms. So this is totally illegal. Right? We will pause there. We will come back to that. So let's go back to number 1. So when I do that, then I can square 2. That becomes 4. And what is the square root of 5 squared? 5, right? The square just undoes the square root. So it's just 4 times 5. And that gives me 20. Okay. Now, if you did this in a calculator, which we're not doing that right now, we need to know how to do this by hand, but the great majority of you would probably get the wrong answer, because that's what I see all the time, but that has to do with you, not with the calculator. Because in the calculator, what a lot of you would do would be 2 square root of 5 and then put a little square on it like that, right? But that is something different. That would just be 2 times 5, which is 10. Do you see the difference there? Because there's not parentheses around it like there is here. You see here, that squared is only on the square root of 5. Here, the square is on both. You see the difference there? So make sure when whether you're using a calculator or not, that you know the difference, but you can't, and the calculator is only as accurate as what you type in. Not that I'm suggesting that you necessarily use a calculator for this, because we have to know how to do it without one as well. We good? All right, so let's jump to number 2. On number 2, this is just, we're going to treat this as if it was something like x plus 5 times x minus 5, right? We don't have any variables in there, but we know how to multiply something like that, right? I believe we've already done that. Use the word FOIL. Everybody know what the FOIL means? First out, and if you do it differently, like distribution or a box that your teacher taught you and you like that better, that's okay. But I'm going to use FOIL here. So I'm going to multiply the first 2 together. 3 times 3 is 9. Outside 2 together, that's going to give me a positive, no, it's not. Sorry about that. It's going to give me a negative 3 square root of 6. Then I multiply the inside 2 together. That gives me a positive 3 square root of 6. And then the last, I'm going to write it out first. Positive times a negative is a negative, and that's negative square root of 6 times the square root of 6. Not saying that you have to write it like that in that step. Just want to make sure I don't lose anybody. So then I'm going to bring down this 9. These are just opposites, right? Those zero out. This is still negative. And then what's the square root of 6 times the square root of 6? 6. Okay, it's just like 6 squared. So you just get 3. Like I said, you don't have to write that. You could have just written 6 here. I just wanted to make sure everybody knew where it was coming from. Okay. Any questions at this point? Okie dokie. Now, we're still multiplying. When you multiply square roots, or things with square roots, you can multiply everything outside together and everything inside together. So I can multiply the 3 times the 2. That gives me 6. And then under the square root, I get 6 times 3. What's 6 times 3? 18. So listen, remember we were adding, the square roots were just along for the ride because we think about them as things or as variables, but when we're multiplying, you actually multiply everything outside, everything inside together. Okay, we good on that? Then if we can reduce, we need to reduce. So this 18, I can break that into what times what? 6 and 3, okay. 3 is a prime number. 6 can become 2 and 3, right? So I can't forget about this guy. This 6 comes down. These 2 3s can come out as a regular 3. This guy stays underneath. So my answer is 18 square roots of 2. Okay. What questions we got? Anything? Okay. So then on 4, we know what we can't do, right? What you should do if there's more than one term is to rewrite it like 3 minus the square root of 6 times 3 minus the square root of 6. Okay, does that part make sense? Then we do like what we did on number 2, we're just going to FOIL it. We multiply the first 2 together. 3 times 3 is 9. Outside 2 together is going to give me negative 3 square root of 6. Inside 2 together, negative 3 square root of 6. Last one, negative times negative is a positive. And what's the square root of 6 times the square root of 6? 6. Okay. Then I can combine everything that doesn't have a square root on it. That gives me 15. And then I have negative 3 square root of 6 minus 3 square root of 6. And that gives me negative 6 square root of 6. And I end up with 2 terms like we do sometimes. What questions do we have? Anything at all? Okay. Number 5. We need to FOIL, right? So let's go ahead and do that. Multiply the first 2 together. 2 times 3 is 6. Outside 2 together, negative 2 square root of 10. When you multiply a whole number times a square root, they just get stuck together. That's all that's happening there. Then inside 2 together, plus 3 square root of 8. Last 2 together, that's going to be a negative square root of what? 80. Okay. At this point right now, can I combine anything? No. But I think I can reduce most, maybe all of those, so I need to try and reduce them. 6 I can't do anything with, right? 2 square root of 10. Well, 10 is just 2 and 5. And then I can't do anything with it, right? So it just stays minus 2 square root of 10. You with me? Can't reduce that one at all. All right, so then I'm going to reduce the 8. That's 4 and 2. So then 2 and 2. And if you want to use some of those little shortcuts I showed you yesterday, that's fine. But there were some people second period that were like, nah, don't do the shortcuts. So I'm just going to do it all the way. If you understand them, you can do it. If you don't, we don't need to. Just do the tree. You're fine. I can't forget about the 3. Oh, I probably shouldn't have circled that one. But the 3's got to come down here. So there's going to be a positive 3. And then these 2's come out as a regular 2. This guy stays underneath. So this becomes plus 6 square roots of 2. So I have this term. So I've got these 3 terms so far. Everybody with me? Then I have 80. So I can make that 8 and 10. Can make the 8, 2, and 4. the 4, 2, and 2, 10, 5, and 2. Right. Then I don't want to lose the fact that I have this negative, so pay attention to that. So that's a negative. And then these 2's can come out as a 2. These 2's can come out as another 2. This 5 stays inside. So that's minus 4 square roots of 5. Don't lose yourself in your own work, which is easy to do. So can I combine any of these terms? No, I still can't. So my answer is 6 minus 2 square roots of 10, then here plus 6 square root of 2 minus 4 square root of 5. And this is my answer. Okay. What questions do you have? All right, now, one of the things that you don't have to do when you're multiplying is to literally multiply them if you're going to have to check to see if they reduce. So like when I did 8 times 10 here, I got 80. That's easy. Even 30 times 6 is easy. But what if I had given you like 27 times 48? Well, you're going to multiply 27 times 48, but then you're going to have to break it back apart, right? So let's just pretend like these are more difficult numbers than they are. And I don't have to actually multiply them. I can leave it as the square root of 30 times 6, okay? Because if we get 180, we're just going to have to get 6 times 30 right back to reduce it. You with me? So I just want you to know that that's an option. Again, making it 180 and then breaking it back apart is fine, but you don't have to do that multiplication. I just start breaking this apart. So 30, I don't know, 3 and 10, and then 10, 2 and 5, and then 6, 2 and 3. I just have more numbers, basically like it's already broken down for me the first time. So it makes it a little easier if you don't, depending on how hard the numbers are. Then I've got, let's see, I've got these 2 3's come out as a 3. These 2 2's come out as a 2, and that 5 stays underneath. So it's 6 square roots of 5. How did you get 2 square roots of 30? 90? Oh, because 90 is not 2 times 30, it's 3 times 30. All right, we good? Questions? So we know what to do and what not to do when we multiply, yes? All right. Flip it over, let's talk about imaginary numbers, which we've already talked about some, right? I think I told y'all at the beginning of this class, and if it's not obvious by now, there's kind of no rhyme. Well, there is rhyme or reason to what we're doing, but the order might seem a little random because I'm just trying to pull some things I know we need to review. We've already talked about imaginary a little bit. It goes with this. That's why we're still doing it with the square roots. But if I was teaching this from scratch, I probably would have started with this instead of starting, just saying, hey, do you remember this? But I know sometimes what we're doing might seem a little random, but I promise it makes sense in my brain for some reason. But here's a little reminder again that I is the square root of -1. So if I square both sides, that means that I squared is equal to -1. Does that make sense to you? Like, we get that? All right. And then we know that this square root of -4 is not a real number. It's imaginary, and it would equal 2i. Right? Got the imaginary stuff down. All right. So let's look at number 1. We're not actually multiplying the 2 terms together like we were on the other side. This is just addition and subtraction, but I've left this one on here because this is what messes some of us up. We have to make sure that we actually distribute that negative, and that this actually gives me 6 plus 9i, and then that's plus 6 plus 4i. So don't mess the easy stuff because we forget to do certain things with our signs. This gives me 12 plus 13i. And when you add, or when you have an imaginary number it should always be in the form of a plus bi, so the I term comes second for sure. Okay, we good? All right. Now number 2, we're going to FOIL, just like we did with anything that's in that form. So let's do the first 2 together. What's 5 times 7? 35. Outside 2, that's going to give me negative 20i. Inside 2, negative 42i. Now, this is going to give me negative times negative is a positive. 6 times 4 is 24. And then I times I is I squared. Okay? What does I squared equal? Negative 1, right? So this is really 24 times negative 1. So if I was to rewrite this, let's see, let's do 35. Let's go ahead and combine these. Negative 62i. But since I squared is negative 1, this is really minus 24 with no i's on it. And what's 35 minus 24? 11. Okay. Any questions about where negative 24 came from? No? We okay with that? Be careful with your eyes. If you don't write this step, it's fine as long as you know what you're doing and where the i's and the negatives are coming from. Okay? All right, let's look at 3. Here's what it doesn't equal. This does not equal 5 squared plus 10i squared. That sends you to math jail. You do not get to distribute that squared. Nobody wants to go to math jail. So what we do is we rewrite this. 5 plus 10i times 5 plus 10i. Then we FOIL it. First 2 together, 5 times 5 is 25. Outside 2 together, 50i. Inside 2 together, 50i. Last 2 together, 10 times 10 is 100. But I squared is what? Negative 1. So that's really minus 100. Okay? Write the extra step in there if you need to. If you don't, that's okay. Whatever. As long as it makes sense to you. So this is going to give me negative 75 plus 100i. Questions? Okay. Now, Victoria, sit up, and everybody put your thinking and paying attention caps on to this next part because it's not difficult, but it's going to look weird, and you're not going to like it if you're anything like second period. Because at the end, I had a whole lot of dirty looks, and I was like, do you understand? And they were like, yes, I just don't like it. So that's okay. We don't have to like it, but we do have to understand it. All right. So before we get into what these are, because I'm going to give you a couple of extra ones on this, let's talk about just powers of I in general. If I have I to the, I keep trying to want to write a T so badly. If I have I to the 0 power, what's anything to the 0 power? 1. Okay. And then if I have I to the first power, that's just I. Okay, we agree with that? Easy enough? So then if I have I squared, we already decided what is I squared? Negative 1. So then what do you think I to the third power is? Wouldn't I to the third power be I squared times I? So I squared times I would be negative I. Okay? Because think about it. You would have I squared is negative 1, and then times another I, that makes that negative I. All right, do you see the pattern right now? 1, I, negative 1, negative I, right? So then I to the fourth Wouldn't that just be I squared times I squared? And that's positive. So I squared times I squared is 1. And guess what? We start over with a little pattern. So then I to the 5th, I to the 6th, and I to the 7th. That's as far as we're going to go. Because I want you to see this pattern. And once you see this, it's going to make everything easy if we understand where this came from. Okay? So we've got 1 I, negative 1, negative I. 1 I, negative 1, negative I. So every 4, it just repeats over and over and over again. We okay with that? So if we at least know this part right here, the first 4, we're golden. That's all we really have to know. Okay? So start with I to the 0, right? Then we have 1, 2, and 3. So that's 1 I, negative 1, negative I. If you can at least understand or figure those 4 out, that's all we need. And here's how we get these, because like I said, I'm going to give you a couple extras that are going to have a whole lot bigger exponents on them. You take the exponent, right? I to the 12th power. We're not going to keep writing this out. We could to 12, but we're not going to. You take 12 and you divide it by, there's 4 possible answers before it repeats. That's like the period, okay? So there's 4. I take the exponent, I divide it by 4 every time I'm dividing by 4. 4 goes into 12 evenly, right? So then that means that I to the 12th is equal to I to the 0 power, because we look at the remainder. There is no remainder when we divide. So since 12 divided by 4, there's a 0 remainder. I to the 12th equals I to the 0 power, and that is 1. And my answer is 1. Okay? That's all you got to do. So let's do 7. I take 7 and I divide it by 4. Now the difference between 4 and 7 is 3, but also when I divide, the remainder is 3, right? Because so somebody asked me, why do we care about the remainder on one and the difference on another? The remainder and the difference is the same if it only goes in there once, just so you know. But it's what we have here is that the remainder is 3. That's what we're looking at, okay? 4 goes into 7 once with the remainder of 3. That means that I to the 7th is the same thing as I to the 3rd, because it's the remainder, because we took out all the repeats sections. And I to the 3rd is negative I, and that's our answer. Ask me a question. Questions on that before I give you another one? All right. I'm going to give you one with a big exponent, so we're not trying to always just repeat the stuff here. Let's see. So for C, we're going to do I to the 117th power. All right. So I'm going to take 117 and I'm going to divide it by 4. We'll just do old school division so that we can get our remainder. 4 goes into 11 twice. 2 times 4 is 8. That gives me 37. 4 goes into 37 how many times? 9. That's 36. So that 29 doesn't mean anything. What I'm looking for is my remainder, which is 1. That means that I to the 117th power is equal to I to the 1st, which is just I. Okay, do you see how you get the repeats out of there? Just kind of taking that, you're just understanding a pattern. That's all we're doing. All right, let me give you one more. I want you to give you a second. I want y'all to do this one on your own. I'm going to do I to the 22nd power. I to the 22nd power. That's a weird looking 2, but it's a 2. I got -1. Did you get -1? Okay. Questions? You just have 4 possible answers. You divide by 4 every time. Get that little pattern written down for yourself, and you can figure them out. Okay? Questions? Anything? Awesome.